Hi, this is Karen O'Brien, and we are going to go over the Mudflow Modeling Part 1, Create a Watershed. So once this is finished, the video link will be in here somewhere. So let's go ahead and just get started. The first step is to load the project. I've already done that, but for you, when you get started, just so you know, the project will look like this. Hold on, I'm trying to get into it. I need to send you this project, so if you need it, go ahead and just ask me for it. It'll have part 1 hydrology, and part 2 will be adding the mud flow to the rainfall and the hydrograph that we build from part 1. So in part 1, you should see this. If you don't, you can extract it from here. And then when you load it into QGIS, the project will look like this. It's not started. All we did was run the settings and load the imagery and a couple of the external layers and saved it. That's all it is. Then we come back to here and we go to load the hydrography map. So that will be step 2. In step 2, there's a link. If the link is broken, just search the web for this National Map Services. It's usually pretty easy. Right click, open in a new tab. In the keyword search, just go hydro or hydrography, whatever you want. And we want the one that's in this area, the theme area. And what you'll do is just right click this and copy the link address. Go back to QGIS and you'll want this data source manager. It needs to be on the WMS tab, and we need a new one, a new service. We'll call this hydrography and pop the URL that we copied into here. So if you lost that because you copied something else in the meantime, just go back to it and grab it again. Just grab that link one more time. Once you're done with that, click OK and then click Connect. Now we don't want everything because this is a pretty simple project. So let's just get the flow line data and we'll click PNG. This looks good, 4326. Make sure this is 4326 right here. And if it's not, just click it and change it. And then let's just call this flow line or flow direction. It doesn't really matter. And click Add. You'll know it worked when you see this right here. If it happens to add it and the whole thing is white instead of this tan color or instead of clear, then just double click it and go to symbol or transparency and set the transparency to 50. I've had it work both ways. I've had it come in with a clean background like this, and I've had it come in completely white and completely opaque. Now we can just pop this down to the end. So what I did is I just dragged it to the right and I dropped it to the bottom of the map. And then we can put it up here above the AOI. And now the next thing would be to double click the elevation layer. And on this one, we want to set the symbology to hillshade. And let's go ahead and give the Z factor a 2 just to make it pop a little bit better. And as you can see, we can really see our watershed very clearly, and we can tell which way the water is moving, and that would help us delineate and define the single watershed that would contribute to the mud flow. So in this case, we have really steep watershed up here, and then it dumps out onto the peneplain around in this area, and that is where kind of the mud flow and everything would concentrate and really do damage. So what you want to do is just review your watershed and make sure using your elevation and using your map, your hydrography data, just make sure that you have a good defined watershed so that you pick up all of the water that could possibly rain onto this area and feed your mud flow area. All right, let's get back here to the instructions. And that takes us to load hydrography, has some instructions here, a GIF, how to set all that up, and then how to add the data. And then it doesn't show it, but in mine, I did have to use the opacity in this one. So if it doesn't come in clear or with a blank background, just go ahead and use the opacity and then set the hillshade. review the watershed like we did. In that case, you also might want to turn off this AOI layer so you can see things a little better. And then you can also check and uncheck these two layers so you can see the image in the background to see where the important features are, such as, the places that you need to account for in the flooding. And then we're on to step 4, create the grid. So now we'll do step 4, create the grid. Step 5, interpolate elevation, and step 6, calculate the roughness. And then we can also save and create our backup recovery point. All right, so we won't go over these. They're all the same for every kind of project. So we just collapse all, open grid. Let's go to create a grid from computational domain, or you can create a grid from the external polygon layer. I'm going to cancel out of this real quick. So if you don't have this fancy little shapefile right here like I have, you can go into your computational domain, and I'm going to turn this off, and you can click edit and then click add a polygon. You only get one polygon in this layer. And then you would use the outline of your watershed to help delineate your computational domain. So it looks like it ends right here. Nope, I did that wrong. Delete and delete. Maybe just go ahead and grab all these. And see, I'm just kind of following the edge of the watershed. And then once you finish it or you're happy with it, you right click, give it a cell size. In this case, we're using 100 and click OK. I'm not going to use this. I'm going to cancel it because I'm going to use, instead, I'm going to use the one that's already in here. So instead, I'll be using this one and I'll click create a grid, use an external polygon layer, and set this to cell size. That has an attribute of 100 feet, cell size, and click OK. If you want to use the align to raster, you can also check and set up and import your raster into this field, and then it would align your grid to the raster. In this case, I have 100 foot cell size. It doesn't really matter. Whoops, cancel. I don't want to do it again. All right, now we're finished with this one, so I'll turn it off. And as you can see, it copied this feature into the computational domain layer and used that to set up the grid. I'm going to turn off the flow line. We're done with that. And the next step will be to add the elevation. So that is this guy, and set that to elevation. I'll show you why we put this as our no data value in a second, and click OK. And then click OK once the sampling is done. And the reason we use the no data value of -999 is because when you create a warp with the GDAL warp tool, what it does is it builds a new elevation raster for you that is perfectly aligned to your grid and has the same, the pixel size is the same as your grid element size. So that's how we interpolate the elevation from this high resolution raster into this low resolution raster. And then we just sample this raster at the centroid of every grid to get the grid element elevation. So that's why you need that -9999. It applies to this raster. Another thing that you can do is you can hit the render elevation button and it'll show you that your elevation map worked. I'm going to turn that off. We don't need that. And instead we'll go to calculate the Mannings. Okay, so we have we want to calculate it for all grids. I have a land soil shapefile here with the Mannings data in it, and I will just select that file and set the field to Manning, and then use a centroid point sample. You can also use the area average. It's a bit slower, but for this project it really wouldn't matter. But I just go with the centroid point sample just to be simple and click OK. What that does is every cell, the center of the cell, will sample this land use raster, or sorry, this land use polygon. It will sample it and set that as your end value for that cell. Okay, let's come back here to our images. And then that is kind of like the setup of the grid is ready to go. You've got your elevation, your Manning, your grid position, and your boundary. Well, we actually don't have the boundary yet, but we have the what I mean is that we have the computational domain boundary, but we don't have the boundary condition. I'm going to save this, and I will now close it because now I want to create the recovery point. I always like to create the recovery point before I do any boundary or any rainfall. So the point of creating the recovery point is in case you mess up your project and you corrupt your geo package or you corrupt your QGZ and you can't continue on. This will give you a drop back point to come back to if you mess up. So I'm going to zip this. And again, 7Z works best for Flow 2D data. It makes it really small and compact. And then whoops, what does that say? I think I just clicked something at the wrong time. So I'm going to ignore that. And then I'll just rename this because the grid is okay, the elevation is okay, and the N value is okay. And so I'm just going to say grid elevation N value okay. Now, if I broke something in this, the simple thing is just to delete it and then extract it from here. Okay, while the video was paused, I went ahead and opened it back up, and now the next step is to determine the total rainfall. So we have another website to take us to the NOAA Atlas. So I'm going to right click here and open this in a new tab. So NOAA Atlas has rainfall and rain and depth area reduction data for every state and every island for the United States. So let's click on California. And I want to show you a couple of things here. So you can click on California and then you can also narrow it down to your area. So if I go to Malibu, that will zoom me into Malibu. And then if I zoom out a little bit, I can show the stations on the map and I can pick a station that might be more appropriate for my watershed. That might be this guy right here. And then I could use that as my starting point to get a rainfall data for my project. Or you can just use the entire project area, which is what I'm going to show you now. So you get a little bit more rainfall if you use the entire project area, or you can zoom in and get more detailed data. It might limit your rainfall to this area. So I'm going to show you this without zooming in. Let's just get the entire southwestern region. Click California, and then go down here and click the supplementary information. And what you get is an ASCII file with gridded data. And we want the 10-year event with the 3-hour rainfall duration, because that's what the USGS uses to do mudflow analysis. So we'll submit this and it will automatically download that to, well, I don't know why it went to documents. It usually goes to download. Yeah, it went to downloads. And it will download that to your download folder. So now I actually already have that in my project folder. So if I come here to hydrology, I've already extracted that data and you can see it right here. I'll just pop that straight into our map. But before I do that, I want to come down here and click on this guy because I don't want that hidden in any of these layers. So just simplify the map, click on the layer I want, and then I'll drag this ASCII file onto the map. Now, when you get this data from NOAA, it's going to be in a different projection, a different coordinate system, and obviously a different resolution. So if you look here, we have the lat-long coordinate system, and then the cell size. Lat-long isn't really a spatially available coordinate system for doing calculations on. So you always need to convert it to the coordinate data that you're needing. However, in this case, we don't actually have to do that because the Flow2D warp tool is going to do that for us. So let me make sure that I covered everything. So we got go to the internet, click California, click the supplementary information, get the project, extract it, put it into your project folder, which we already have it, drag the data onto your map, and now we are going to sample the rainfall raster and set up the rainfall. So first, let's use this ID tool. And what we're going to do, what we see here is that we have the rainfall value for this raster covers the entire southwestern region. So we don't actually need all that data, but it's okay. We can use it, no problem. So let's go ahead and zoom back to our project. And if I do that, if I click the computational domain and then zoom back into that, then I can come down here, click on that again, and we can use the ID tool to sample this. So if I hit ID and I just start clicking these pixels, you'll see that I get some rainfall information. This represents 2.978 inches of rainfall. If I click down here, you'll see that I get 1.579 inches of rainfall. So this is a coastal mountainous region along the coast of California. So as you can see, as the water would move along the coast, as the atmospheric um, weather and rainfall patterns and precipitation, as this air moves across the Pacific Ocean, it's going to hit the coastline and it's going to start rushing up to these higher elevations. And as it does that, it's going to condense and they're going to have a higher precipitation on the top and a lower precipitation on the bottom. Now, here's my disclaimer. I'm not a hydrologist, so I can only tell you like the very basic way to use this data. If you have a small watershed, this method I'm showing you is probably fine. But if you have a large watershed or multiple domains or whatever, then you need to get with your hydrology crew or team or get with your county and read their hydrology manual, get with HEC HMS or HydroCAD and read those programs and figure out how to set up the rainfall data correctly for Flow 2D. Because I think that the method I'm using is only okay for small watersheds, and it might give you too much rainfall if you did this on a big watershed. So let me zoom in here and get this value again. So again, I'm picking up that highest pixel and we have 2.978 inches of rainfall. Now that's the value I'm going to put into the rain editor. So over here, click the rain editor, check to simulate rainfall, and put the 2.978 inches in here. We will need a time distribution. I don't have a 3-hour rainfall, so I'm just going to use a 6-hour pattern. If you want to develop a 3-hour pattern, you might find one in HEC HMS. You might find a 3-hour pattern in HydroCAD, or you might, if you do a Google search online, I think the Army Corps of Engineers has developed a 3-hour rainfall pattern for California. So I'm going to use the 6-hour pattern one because it's easy. And as you can see, it sets up an nice and easy rainfall pattern. And we're going to run this out past this to maybe 10, 24 hours to make sure we get full drainage. So you'll see that when we set up the controls right here. Now we need to check the spatially variable depth area reduction. This is what is going to sample this layer using the same sampling as our elevation sample, except this time we want a maximum, and click OK. And click OK again. We're now finished with this, so we can turn it off and put it to the bottom. And we're finished with this one. And now we have in our rain tables, we have a table called rain ARF cells. If I right click on this and I open it, you'll see that this is the rain ARF value that we've assigned to every cell. So if I sort this high to low, you will see that grid element number 5249 has a value of 2.978. So that is 100% rainfall. So when I export the data, the rain ARF data will be exported. This field will have a 1, and anything less than this will have a factor. So it'll be 2481 over the max gives you the rainfall reduction factor, and that will be applied to your total rainfall so that every grid element, instead of getting the full amount of rainfall, instead of getting the full amount of rainfall of 2.978, it will get the reduced amount of rainfall, 2.481. Now it's okay that this is not in rainfall in inches because the rain R value is a factor. All right, so I'm gonna close this, and the rainfall is ready, so we can just turn this off. And the next step, I believe, will be to do the infiltration. So we did sample the rainfall, we did set up the rainfall, and yeah, I just used the wrong decimal place right there. The next step will be to set up the infiltration. So we need to generate the curve number data. We're going to use a new plugin called the curve number generator to do that. So come back here, go to plugins, manage and install. And what you'll want to do is search for the word curve, and you'll see that you have the curve number generator. If you don't have it installed already, it will be green. If you have it installed, you might be able to update it or install it right here. And then once you do that, that goes plugins, curve number, and then just click the curve number generator. Now this is a processor module, so the cool thing is you still have opportunity to come over here and work on the map while your model is here. It doesn't lock your map, so it's really handy. Let's set the area boundary to grid, and I just check all of these. I don't think you need them all, but I just check them all anyway. And then it's going to use the embedded lookup table from the regular curve number lookup tables. So if your area uses something slightly different, you can change your lookup table with your own curve number CSV file right here. I'm just going to use what they provided online because it's just the one straight out of the TR55. And I'll click run, and we'll let that run. It doesn't take very long because it's a small project. Now, if you have a large project, because curve numbers are only really supposed to be used on small watersheds, this program is limited in the amount of area that you can apply it to. So if you're going to use it on a larger area, you might need to do this more than once. But if you're going to use this on a larger area, the curve number might not be appropriate. You might want to go to the green amped infiltration system instead. But I've seen people use it on bigger projects. They do it in the southwestern United States, and they do it on solar projects. So I think if you want to try it, that's at your discretion. I'm going to close this because we're finished with it, and we can come over here and see what we have. So we were given, this was what it calculated, this was what it generated, was the curve number layer. It generated that from the land cover raster, the impervious raster, the soil layer, and this was just a land cover vector. We didn't really need this. So we don't need these anymore because the calculation was applied here. But if you want to keep them, recognize that these are scratch layers. So if you close QGIS, they're gone. So if you want to keep these, just right click, export, and save them as whatever you want to save them, and that will keep them in your map and keep them with your project data. I'm not going to do it because it's so easy to get them. I'm just going to leave it as a scratch layer. Now, what I do want though, and I don't need these anymore, so I'll turn those off. And what I need, let's see, yeah, this one, sorry. What I do need is this guy right here. And as you can see, it is snapped and to our grid. So the data is not only downloaded by the curve number generator, but it's also reprojected and clipped to your project area. So that's actually pretty cool. Now, if I come over here and I clip and I click the infiltration tab right here, I want to set up my global infiltration to use the global SCS and click OK. And now down here, I want to calculate from the shape file. So I'm going to use the first option, set this to curve number layer, set this to curve number field, and click OK. And it's that simple. The curve number calculation is finished. If you have a larger project, it's going to take longer. I only have 9,000 cells, so it's almost instantaneous. Okay, now we're finished with this, and we are starting to get quite a bit of data down here. So some of the things that you can do to manage this data is you can group it. So let's call this curve number. Well, let's just call it CN. and enter. And then we can close these down. That will hide that data. And we can take this one. Let's do this one. And we can group that in hydrology. And again, we can trim the fat. That's what we're doing. We're just managing this to trim the fat. And then I put this one, I don't know, these kind of go together. I can just leave those as is and minimize that. Just a little bit of housekeeping. Click save so that it remembers that. And the next step is to set up the rainfall, generate the curve number, shows you all the instructions for that, calculate the infiltration, shows you all of the instructions on how to do that, and it shows you how to review the data that you just created. So if you want to do that, you come up here to the infiltration layers and you right-click the areas SCS and you open the attribute table, and then you can sort this from high to low. Now we do have one in here that has 100%, a curve number of 100%. Now if you have a curve number, sorry, it's not 100%, it's a curve number of 100. If you have a curve number that is greater than 99, when Flow2D reads that data, it's just going to reset it to 99 because we don't use a curve number of 100. We only go up from like maybe 34 up to 99. So just recognize that. Oh, 33. So yeah, whatever the lowest, I think the lowest is like maybe 25 and then up to 99. So if this will just be reset by the engine to 99, so you're perfectly fine. Now, if you see values in here like decimal values or values that are greater than 100, something's wrong with the layer that you use to calculate your curve number with, and you might need to use a curve number raster instead. So if you're getting bad data from your curve number polygons, just save those polygons as a raster with the curve number field. The raster will do the averaging and then just sample the curve number to your, I don't know, your elevation or something like that, or maybe even your N value, and then just copy that data into this layer. It's actually pretty simple. Okay. So we're done with infiltration. The next step will be, save, export, and run, because we need to do a quick run to locate where we want to put our floodplain cross section. The floodplain cross section will get our hydrograph for the next model. So first, let's do the setup of the control variables. I'm going to just run this out to 24 hours because that'll just make sure that everything drains. 10 would probably do it. Just do it for 24 just to be safe. 0.1 is our output interval. We can run it in detailed graphics or we can run it in text mode. Text mode is faster, but it's a small project, so detailed graphics is fine. 0.1 is the update interval for detailed graphics. Let's see. I don't think I need anything over here. Make sure to turn on your switches. Set this to 3 so that you can find any pits you might have in your data and click save. Numerical stability parameters were fine. They were just default. Now let's go ahead with the export. We got everything turned on. I think I actually am going to go ahead and on my other screen, I'm just going to make sure that file is empty because I know I've already done this once. So I'm just going to delete everything in there. And okay, and now I can export it here and save and click OK. And as you can see, this is what I just exported. So cont.dat is your control data, and infill.dat is your curve number data. Mannings is your roughness on the floodplain. Here's your rainfall. Up on top, you see your rain curve goes from 0 to 6 hours on the left, and 0 to 1 on the right represents the percent cumulative rainfall over time. So it's not 0 to 100%, it's 0 to 1. It's a fraction, okay? That way Flow2D does the math super easy. And then of course down here we have the rain ARFs. So this cell will get 91.1% of the 2.978 inches of rainfall. And this is just the switch telling you that you're using a rain ARF. Nothing else is really important in here. Okay, now let's go back here and see where we're at. Oh, we need to run it. Sorry. Okay, so I have two ways to run it. You can either pop your engine in here with all of its DLLs and just double click it and it'll run, or you can run it from here. This goes to the Flow 2D Pro folder. This goes to the project folder. You click OK and then wait for it to start. Okay, once it starts and you see this window, that means all its checks are finished, and you can click minimize this. And then over here, this is just a bug. It'll be fixed in the next version, so just click OK and ignore that. Now, once that's finished running, we're going to read the results in Mapper, and then we'll plot the velocity vectors in Mapper and then pull that data into Flow 2D. So I'll pause the recording until it's done, and then we'll go ahead and load it into Mapper. Okay, so I just wanted to show on this map a couple of the issues that we want. So first of all, we can see that our points of concentration are going to be pretty accurate right here. I also got a screenshot of when there was a bit more water on it here. And we can also see that this bridge is kind of the confining location of our project. There's a bridge right here. So we need an outflow node on that bridge. So these are things that we need: a floodplain cross-section and an outflow node. So I'm going to just let this do its thing. It can stop. And then the next step will be to map it in Mapper. So let's go ahead and run Mapper. And yep, everything's fine. Just click OK. And once you're in Mapper, it won't remember like this path. So you might need to copy this path or just find this path, this location. I turn my layout off, turn my navigation pane off, but you can see that and this is in C drive. In my case, C drive projects, module 5, watershed export, and then just grab the fplane.dat and open it. Here's your elevation, and we need velocity vectors. We don't need depth. And so you can see our points of concentration pretty clearly from these velocity vectors. I'm going to close this down. We don't need any other data. And I'll just take that shapefile that was just created by Mapper. So every time you click a map in Mapper, it creates a shapefile for you, and we'll just drag that onto the map. It does not have a coordinate system, so I have set up QGIS to automatically apply the project coordinate shapefile to any data that doesn't have a coordinate system. Let's put this down here. Wait, where did I put it? I put it in here. Sorry, I meant to put this like right here. Okay. And let's turn off the image so we can see things a little bit better. Maybe turn off the elevation, maybe turn off the grid. So we don't need that. And we don't need infiltration. And we don't need that. Well, whatever, that's fine. And well, we do need the image because we do need to see where it's obvious that Mudflow is kind of depositing once it gets down here to the top of the fan. And it looks to me like there's possibly some deposited material right here where things start getting flat and people start putting their homes in here. That's where your Mudflow wants to drop out once it's running down here and start filling in this area. Okay, so we need a floodplain cross-section just above this so that it captures all the water crossing this line. And that's easy to do. You just come in here. Well, first of all, let's make these velocity vectors a little bit more visible so they're useful to us. Let's just make them a darker color. Let's go with darker color. I want to do like red. Yeah, there we go. And I don't think the stroke width is necessary. Yeah, that's better. And then we do the floodplain cross section on this side. Just create a floodplain cross section. And what you want is you want your vectors to be going across it. So if they're going sideways or they're going back upstream, that's not helpful. And we want to get all the potential sources of water that might, bring in water and bring in mud flow. So you can see up here, the sources of the mud flow are kind of coming from the sides here. So we want to be above that. So we can put it like right here, right click, the flow direction. Yeah, don't worry about the flow direction. We'll name it. Let's just call this cross section 1. Doesn't honestly matter. And then we click save, and then we give it a flow direction, which is south, and then we click schematize. And then that will convert that cross section to Flow 2D data. Okay, so these are our 4 cells that are going to pick up the water that flows across it and gives us the hydrograph that we're going to put back into the model to run the mudflow model. And that'll be on the next training. Okay, so we're finished with this. And we also, actually, no, we're not, I'm sorry, we're not finished with that. We also need a outflow node. And it looks like all our water is gathering right here because it's supposed to be going through the bridge. So the bridge is blocking it and storing it in this big spot right here. So all we need to do is add an outflow node anywhere in this location. So if I go boundary conditions, add a point, we only need one. It's no big deal. It's just going to take everything and put it into a sink. This becomes an outflow node. So I just clicked it. I clicked anywhere in here, set it to outflow node, click save, click OK, go to the outflow side of the widget and change this to floodplain outflow node number 1, and then schematize it. So we can see here that it worked. Now we'll save it, and let's see. I'm going to come back here and look at this again just to make sure that I saw everything I wanted to do. So wait, where's that final one? Oh, I turned it off. So we got our outflow node, we got our floodplain cross section. So now we need to export it and run it again. So back up here, we don't need to turn on any extra switches because floodplain cross sections don't require a switch and outflow nodes don't require a switch. So this is fine. We just do output here, but you see that we do have outflow elements and floodplain cross sections. So I'm just going to put this right back in the same folder. And this time, instead of running it from here, I'll run it from here so you can see both processes. And while it's running, I'm just going to wait for it. And as soon as it starts, we'll minimize it. And then the way that you do this is you come to the Flow Pro folder, open it up, open up Run for Project folder, and just copy all of these into that folder. We'll also need the Hydrog. Now you can either run Hydrog from here, or you can do it the exact same way. You can run it from here. So you copy this and put it into your project folder. Just going to get us back to our project folder, and you can see that we have all those files. And then you just double click this to run the model, or you double click this to run Hydrog. This should be, nope. Okay, I'm going to pause until it's finished. Okay, so the project is almost done. So I just wanted to show a couple things here. See, there's a couple of pits in this watershed. So whenever you do a floodplain and you model a watershed, if you have pits like this, that could be an issue because it means that not all the water is moving downstream, and it probably should be. So I will probably add a side video on the end of this tutorial on how to fix pits. Just wanted to let you know that. All right, let's go back here. Now, what we have is in our results is a hydrograph that crosses this line. So if you run Hydrog right here, it's going to pick up the Hydrog from the Flow2D folder and apply it to the project folder. And what we have is that floodplain cross section, right? So if I click on that, and I click here, I click OK. This is the hydrograph that crossed that point. And so you can see that we probably needed to run it, out here a little bit farther. You want to run it until the velocity on the floodplain is almost zero. That's kind of what you want to do with mudflow modeling. But obviously there's no mudflow in this yet. So I think running it to 24 hours is good. But what we do need is we do need to print this to text. So what I did, let's start over. I'm going too fast. So what I did was I plotted the cross section, but now I need to click return to menu and then print this file, or print this to a text file. And now what we get is an ASCII file, ASCII text, with the number 1 in it. And I'm actually done with Hydrog now, so I can close this. Go back to the project location and look for the number 1 right here and open that in Notepad or Notepad++. I'm going to do it with Notepad++ because I need to edit it, because I want to use it in my project filer. Okay, so I need to get rid of this line because this will become the inflow node for my downstream watershed model. So get rid of that, and I want to click edit and blank line or blank operations and trim the spaces. And then I want to turn these spaces into tabs. So what I need is 1 tab. So I'm going to hit tab. Let me show you what I just did. I want to show the symbols, and I just changed these spaces into a single tab. I'm going to copy that tab, and I'm going to hit Control H. If you're on a computer in a different language, it might be Control R. And then I'm going to put spaces in here. Wait, actually, sorry. I need to get this down to only 1 space. So I need to replace these spaces. So Control H, and that should be spaces. Yeah, that's spaces. And just replace with 1 space and replace all. Oh, come on. Copy, paste, replace all. Dude, seriously. Let me try that again. Copy, paste. All right, let's try this. Let's go 1, 2, 3, 4, 5, replace all. Hang on. Replace all. This normally works. What am I doing wrong? Oh, stupid. I don't know why I had that checked. Okay, replace all. And then we'll do that again. 1, 2, 3, 4, replace all. And then let's just do 1, 2, replace all, and just hit that until this becomes 0. Now you only have 1 space. Now you get your tab, copy the tab, It needs to go here. And this just becomes 1 space and replace all. Or you can do it in Excel and get tabs that way. Either way, I think this way is faster. And then we will grab this information here and copy it. And then back here, well, actually, no, I don't know that I need to copy that. I just need to save it, right? Yeah, just save it, okay? Control S. And then this is ready to be imported into our project for the next set for part 2. So what I'll do is I will name it. Let's call this Hydrograph 1, 3-year 10-hour.txt. And that is ready to go into the Mudflow. So copy, and I'll just put that right here into here. Okay, and that's ready to go. All right, now the next thing is, or let me just see what the instructions are telling us to do. So we did the save, export, and run. We mapped the velocity vectors. We created the floodplain cross section and we ran it again, and that's the end. The next step would be to go on to part 2 and do the set up the Mudflow. So that will be the next video. So I'm going to stop the recording here, and yeah, that's it.